Okay, I'm just going to randomly do a few questions from your homework. Hopefully this will help you figure out how to set the proportions up. When you're doing proportions, it's all about creating a pattern, and you just have to keep the same pattern. So what do I mean by that? Um, if I were to look at this question number one over here, I could think of this as a piece, and then this as a piece, and then maybe I'll think of this green over here, AB, and AE is a piece. So there's lots of ways I can set up the proportion. So if I started with AB, that's a green piece, and it happens to be proportional to the other green piece. So I could say AB over 10. And then because I started with AB on the left, that was the first one that I started with, I need to start with the corresponding other pieces, the red pieces. So I need to start with the left. So I would say 5 over 6. Okay, so that's one way to think of it. So sometimes I go what I would consider saying um, top to bottom, top to bottom. See how there was a pattern there? Okay, so that's one pattern. The other pattern that you could think of maybe is going same side to same side. So I could say, okay, I'm going to start with AB to 5. So I would go AB, which is green, and then I would go 5. Okay, but I have to keep the same pattern. Since I started with the green piece first, on the other side, I have to start with the green piece, and I'd have to go 10 to 6. So then it would be 10 over 6. Okay, so these two are both equal proportions. They don't look the same. If you look at them in the same like fraction top to bottom, they don't look the same, but they are equal proportions because if you take and you do cross multiplication here and you multiply the diagonals, you end up with 6 times AB equals 5 times 10. Okay, on the other one, what do we end up with? 6 times AB equals 5 times 10. So it doesn't matter how you set up your proportion, but if you're doing true proportions, when you cross multiply the diagonals, you will always get the same equation that it's equal to. So I could go the red ones first. I could do the 5 over 6. It doesn't matter as long as you keep a pattern. Okay, let's try another one. Let me go find another one. Okay, if we were gonna kind of think of these sides like we did the last one, what compares with what, I would go with this red ST and TR. Those are considered the same in proportion because of the parallel line theorem. You've got two triangles that are nested in each other, and these lines right here are parallel. So that's telling us how these other sides can be in proportion. So then this one can be in proportion right here. Green matches with this piece over here. Okay, so remember, whatever I do, I have to keep a pattern. So I could start here and I could go 7 to 2x plus 4. So keeping the pattern, I started with the red and then I went to the green, so I got to go 5 to 3x minus 5. That would be one pattern. So what do we say? We could say 7 over 2x plus 4 equals 5 over 3x minus 5. Okay, that's one way. All right, what's another way to set up the pattern? We could go left to right. I could say 7 to 5. And so 7 to 5. So 7 to 5. Now you have to keep oops, let's do that in red since that's red. 7 to 5 equals, and then we'll go. Now, since I started with the 7 on the left, I have to start with that same pattern. So I'm going to go 2x plus 4 goes to 3x minus 5. So 2x plus 4 equals 3x minus 5. So if we cross multiply, do we end up with the same thing? Well, we would in either one. I'll just solve the one on the top. So we're going to go 7 times 3x minus 5 equals 5 times 2x plus 4. So I don't always do the same setup. So maybe that's what's confusing you, because sometimes I go left to right, sometimes I go up to down, up and down. But whatever I do, I'm keeping the same pattern. I'm keeping a pattern to whatever my process is. There has to be a pattern in your proportion. Okay, oops, I forgot my x. So 11x equals, did I do that right? 7 times 3, 21. 7 times 5, no, I was talking and I can't talk and multiply at the same time. Let's redo that. 21x minus 35 equals 10x plus 20. Okay, and then we're going to end up with 11x, because we're going to minus 10 from here. And then we're going to add 35. And we're going to end up with 55. So x is going to turn out to be 5. Okay, now this next one that I'm going to do is the one that is the most missed. So what I'm going to do here is I'm going to separate these two triangles so you can see how they are nested inside each other. So this top triangle, TSR, that I've got labeled in red, I'm going to go and I'm going to draw it separate. So here's TSR. And we kind of labeled those sides, the red sides right here. So I'm going to go ahead and do that. Okay, now I'm going to draw the other one, the other triangle that it's nested inside of. So it kind of goes bigger like this. Okay, and then this would be, T would be here. This would be S. This would be P. Here would be R. And here would be Q. Okay, so in our picture, this piece right here is the green piece, and this is the green piece. Okay, we're supposed to find y. Now, in this triangle right here, y happens to be the base here, and it matches with 18 over here. Now, this is what most students want to do, and this is wrong. So I'll show you what most kids do, and we'll talk about why is it wrong. So this side right here happens to be 7. And then this is what most students do. And then this piece right here, we knew what x was 5. So 2 times 5 is 10, plus this green piece is 14. This is 14, 15 minus 5, and this side's 10. Okay? So this is what most students do, because they come up here and they look at this triangle right here in the top without looking at the separated piece, and they will do this. They will say, oh, 7 goes to y. Okay, that looks like that should work. 7 goes to y. That looks like it's corresponding. And then they go this piece to this piece, right? The green to the bottom. Okay, so then that would be 14 to 18. Okay, let's check out why is that wrong. Let's come over here to where we have it simplified in two triangles. So the first thing you did was 7 over y, and then you did 14 over 18. Okay, the reason why this doesn't work is if you look in the little triangle, remember I said there always has to be a pattern here that you have to follow. In the little triangle, this 7 is a complete side right here. This 7 right here is a complete side. And the letter y is a complete side. But if you come over here into the big triangle, 18 is a complete side, but 14 is not. That's not keeping a pattern. This is saying a complete side, a complete side. This is part of a side, and this is a complete side. That's not keeping a pattern. Okay, you either have to go complete side, part of a side to part of a side, or it has to match. You've got your fractions have to match the same types of segments that you're using. So to finish this one out, what you would have to do is you'd have to say, okay, well, if I'm going to come back over here, I'm going to go 7 to y. That's a complete side over complete side equals. Well, then I must need the complete side over here on this one. Well, what is it? It's 14 plus 7. So that's got to be 21 over 18, and then you can solve it for the letter y. So the tricky one on this, when you have your nested triangles, the two similar triangles, is when you're trying to find the base, so to speak, this side right here, this base side at the bottom, because it really doesn't match up with anything, these two sides right here. If you're using these, the parallel sides, you really got to think about how you're setting up your proportion. You got to be really careful. The other ones usually fall into place, but if you're looking for the parallel sides, the proportional parallel sides, you got to be really careful how you set up that proportion. Okay, just two more, and then hopefully you'll know how to do it. If not, email me and a few more questions, and maybe we can get you straightened out. Maybe you've already got it figured out and you don't even need these two. If so, turn the video off. Okay, so we got to figure out a proportion to make. So this one is that we've got all these parallel lines here. And so it's dividing these two sides proportionally. That's what's happening. That's what that theorem says. So once again, think of a pattern. Okay, so there's lots of ways to write it. So my pattern proportional wise, I could go top to bottom. I could say 35 to 40. That could work. 35 to 40. Okay, but remember, we got to keep the pattern. So then I've got to go, since I started with a 35, I'd have to go 21 to x. Okay, that's one way to set it up. Okay, let's go left to right. So I could go 35 to 21. Okay, but since I started on the left, that means I got to go 40 to x as the other one. Okay, let's do one where we go right to left and bottom to top. So let's say I go x to 21. So then since I started with the bottom, I got to go 40 to 35. So doesn't matter how I did that. I kept a system. And if I check all my diagonals, they better all be 35x equals 40 times 21. Are they? 35x, 40 times 21, 35x, and 40 times 21. So they all work. So different, I mean, there's not one right proportion. You just have to keep the pattern. So over here, this one is the angle bisector. So if this angle is bisected, then it cuts this piece in proportion with this one, and this piece is proportional to this one, right? So same thing, you can if we're looking for this piece right here, lots of ways we can do it. I could go 17 to 21 or 17 to x. So notice how I went kind of on the side of the triangle to the base. So that's 17 to x. So then I would have to keep that same pattern and go 34 to 21. Okay, so that's one way I could think of the proportion. Okay, I could go left to right. So I could say, well, 17, the side, goes with the side to the other one. 17 over 34. Then that means, now it matters, since I started with the 17 on the left, I got to start with the x that's on the left. So that would be x over, and then 21. Okay. And then let's just do a quick check. Do those work? Our diagonals should be the same, and they are. So if your diagonals aren't the same, then can't be a true, whichever one you did. So if you want to try two different ways to check it out, you can, but those were all true proportions. So that's why it's a little confusing because there's not one right way to do it. It's just a pattern and you have to keep the pattern. Okay, hope this helps.